Alright, so once we've identified all of our keywords and stuff like that, we're going to go into creating our system of equations, alright? So you got to think about what two things we're talking about here. Alright, in this application, we're talking about the number of threes Trevor has made, and we're talking about the number of threes Joe has made. So Trevor, he doesn't start with any threes, he gets to practice late. So he doesn't start with anything, and he makes 4 threes per minute. Joe starts with 6 threes. He's made 6 before Trevor shows up. So he starts with 6 threes, and he makes 2 every minute. So that means if nothing else happens, if they decide to go home and skip practice that day, Joe has already made 6 threes. Trevor hasn't made any threes. Alright, so once we have our system, one of the ways, and the way that we're going to talk about today, of solving systems of equations is just by graphing the two lines on the same graph, seeing where they intersect, looking at what that means. Okay, so here's our graph down here. Let's look at what the axes are going to stand for. Our x variable, or our n's up here, are going to stand for the number of minutes, so that's going to be our x-axis. So our x-axis is minutes, our y-axis is total threes. So that's what our y-axis is going to be down here too. Alright, so now let's go ahead and graph these. Joe has a y-intercept of 6. Let's graph Joe in green. Joe has a y-intercept of 6, so we'll start at 6, and he makes 2 threes for every minute. So that's his rate of change. So when he goes up 2 threes, it's been a minute. When he goes up another 2 threes, it's been a minute. When he goes up another 2 threes, it's been a minute. So there's Joe's line of threes. Let's graph Trevor up here in red. So Trevor doesn't have a y-intercept. At 0 minutes, he's made 0 threes. He makes 4 threes for every minute, so his rate of change is 4 over 1. So he's going to go up 4 for a minute has passed. Up another 4 for a minute has passed. Up another 4 for a minute has passed. That's one of the worst lines I've ever seen. That's alright. So look at where they're going to intersect each other. Alright, they're going to intersect each other at the point 312. So now think about what that means in the context of the problem. Our x values, our input values, our n's up here stood for number of minutes. We identified that a lot of times at the beginning. Okay, so at how many minutes have they made the same number of threes? They've made the same number of threes at 3 minutes. How many threes have they made at that time? Well, the total number of threes was our y's, so they've made 12 threes at that time. So there's one way of solving an application problem with systems. We'll talk about more ways in the video for tomorrow. Alright, so systems of linear equations, that's what you guys just saw. That was an application of systems. What they are, they're a set of 2 or more linear equations that are going to be true at the same time. Just like you saw in the last problem. There was Trevor's equation, there was Joe's equation. We wanted to know when they were true at the same time. The solution makes all the linear equations true. Our solution in the last problem, at 3 minutes and at 12 threes made, that's the number of threes they had both made at 3 minutes. It made both of their equations true. And the solution point will be the point of intersection. That's what we looked at last time. If we want to find the point where both of those equations are going to be true, then the point has to be on both of those lines. The only point that's going to be on both of those lines is the point of intersection. So let's look at some more of those example problems. So if we're going to solve this system by graphing, there's 3 steps that we're going to look at. Step 1 is going to be graph the equations. So first thing we're going to do, we have equation 1, we have equation 2. Let's look at equation 1 first. Alright? We're going to solve for y, because once we solve for y, we'll have it in slope-intercept form. We can identify the slope, we can identify the intercept, and we can easily graph that line. Alright? So equation 1's work is going to be down here. We have negative y equals negative x minus 1. And then to solve for y, we're going to divide both sides by negative 1. Remember, when we divide both sides, we're going to divide by every term on that side. So negative x divided by negative 1, negatives would cancel out, just be x. Negative 1 divided by negative 1 would be a positive 1. Alright, so let's look at equation 2. Alright, same thing here. Add or subtract stuff to get away from y. We're going to have negative 2y equals negative 4x minus 8. And then multiply or divide stuff to get y by itself. So we're going to divide both sides by negative 2. We're going to divide every term by negative 2. So negative 4 over negative 2 is a positive 2. Negative 8 over negative 2 is a positive 4. And then we're going to graph those. So let's graph equation 1 in green up here. So y equals x plus 1. Ask yourself, what is the y-intercept? What is y going to be when x is 0? Well, when x is 0, y is going to be 1. So we have a point at 0, 1. And ask yourself what the slope is. How much does it go up for every one that it goes over? Slope is rise over run. So our slope here is going to be 1. So we're going to go up 1 to the right 1, or down 1 to the left 1. And go ahead and draw in your line. So let's go ahead and graph equation 2 in red. Equation 2, ask yourself, what is the y-intercept? The y-intercept is going to be 4. And then what is the slope? The slope is going to be 2 over 1. Remember, slope is rise over run. So we're rising 2, running 1. Or we could go down 2 to the left 1, down 2 to the left 1, down 2 to the left 1. And what I do with systems and what I just did up there without thinking about it is you're going to make enough points until you can see where they're going to intersect. Okay, so I made more points on this red line than on this green line. That's just because I wanted to find an exact point where they were going to intersect. All right. So then, where do they intersect? They intersect at negative 3, negative 2. So there was step 2. Write your answer as an ordered pair. Because your answer is going to be a point on the graph, so we need to express that as an ordered pair. And then step 3, we're going to check our answer. And we're going to check the answer by substituting our x and y of our answer back into the original system, and we said that the solution of our system is going to be the point at which it makes both of those equations true. Okay, so we're going to substitute both of those in to both of our equations in the original system, and we're going to see if they're both true, because that's what a solution to a system is. Alright, so let's check equation 1 up here. Negative 3 minus a negative 2 equals negative 1. Subtracting negative is the same thing as adding a positive. So negative 3 plus 2 would be negative 1 equals negative 1. Alright, so equation 1 is good. Let's look at equation 2. 4 times negative 3 minus 2 times negative 2 is going to equal negative 8. 4 times negative 3 is negative 12. Negative 2 times negative 2 is a positive 4. Negative 12 plus a positive 4 would be negative 8. And that equals negative 8. Okay, so we're good there. So our solution works. Alright, so negative 3, negative 2, it works. Let's look at another example here. A little bit different one. Alright, step 1 is going to be the same thing. We're going to graph both of our equations. Alright, equation 1 in this one is already in slope-intercept form, so we don't have to do any algebraic work there. So let's look at equation 2. We're trying to get y by itself. So we're going to add 2x to both sides. Then we have y minus 3 equals 2x. That's a plus sign there. And then we're going to add 3 to both sides. Still try to get y by itself. Get in slope-intercept form. We're going to have y equals 2x plus 3. Okay? So let's do the top equation in green. Ask yourself, what is the y-intercept? The y-intercept there is going to be 3. And then what is your slope? Your slope is 2 over 1, rise over run. So up 2 over 1, or down 2 to the left 1. And there's your line. Alright, let's do equation 2 in red here. What's your y-intercept? The y-intercept is 3 again. What's your slope? The slope is 2 again. So we're going to go up 2 over 1, or down 2 to the left 1. We got the same line. What does that mean? What type of point makes both of those equations true? Well, all the points on the lines make the equations true. They turn out to be the same line. All right? So that brings us to a couple of special cases with systems that we're looking at. When the lines are parallel, we said the solution of a system is when the lines would intersect. If the lines are going to be parallel, by definition, they're not going to intersect, so there's going to be no solution. Intersecting lines, when they have one point in common, that's the only point that makes both of those equations true. It's the only point on both of the lines. So your answer is going to be one solution. It's going to be one ordered pair. Okay? When there are coincident lines, which is what we just looked at, it's when they turn out to be the same line, and all the points on that line are in common to both lines because they're the same line. So there's an infinite number of solutions, and all the solutions are points on that line. All right, let's look at two more examples. All right, step one was going to be graph both of our equations. So let's look at equation 1. Let's solve for y, get it in slope-intercept form. We're going to add x on both sides, so then we have negative y equals x plus 2. Divide both sides by negative 1. Divide every term by the negative 1. So we're going to have y equals negative x minus 2. Alright. Now let's look at equation 2. Get that in slope-intercept form so we can graph it easier. Subtract 2x on both sides. So then we'll have 3y equals negative 2x minus 3. And then multiply or divide what we need to get y by itself. So we're going to divide both sides by 3. So y is going to equal negative 2/3 x minus 1. Alright, so let's go up. Let's graph those. Let's graph equation 1 in green. So what is your y-intercept? Your y-intercept is going to be negative 2. What's your slope? What are you multiplying x by? You multiply x by negative 1. So you're going to go down 1 to the right 1, or up 1 to the left 1. Let's go ahead and graph equation 2 in red. What's your y-intercept? Your y-intercept is negative 1. Remember, y-intercept is what y is going to be when x is 0, when it crosses that y-axis. What is your slope? It's negative 2/3, so go down 2 over 3, or up 2 to the left 3. And there's our line. It's hard to see. Hopefully you drew a better graph than I did. But you should have gotten an answer that was at the point negative 3, 1. That's what my graph should show. Okay, so there was step 2. Step 1 was graph both the equations. Step 2 was write your answer as an ordered pair. It's a point on a graph, so we need to write it as an ordered pair. Step 3, check your stuff. Alright, so let's check it in equation 1. Negative 3 is your x value. 1 is your y value. So negative 1 times negative 3 is a positive 3. Does 3 minus 1 equal 2? Absolutely it does. So we're good with equation 1. Let's check out equation 2. 2 times negative 3 plus 3 times 1. Is that going to equal negative 3? 2 times negative 3 is going to be negative 6 plus 3. Is that equal to negative 3? Is negative 6 plus 3 equal to negative 3? Absolutely it is. Okay? So negative 3, 1 is a good solution. We're good there. Let's go ahead and look at the last one. Alright, so now what I want you to do, I want you to stop the video for a second. I want you guys to try this one on your own. When you've done this one on your own, turn the video back on, assess yourself. Okay? Make sure you know how to do this. This is our last example. So by this point, we should be mastering that objective. Alright? We should be able to solve a system by graphing. Alright? So try it on your own. See if you've mastered it. Alright, when you're ready to continue, then check your work.